Good morning students. In today's session we'll discuss about isotonic solution, hypertonic solution and hypotonic solution. It's actually a continuation of our osmotic pressure. So we will see first what are isotonic solutions. Two solutions having same osmotic pressure at a given temperature, they are called isotonic solution. So if you are taking two solutions and both the solutions are having same osmotic pressure at a given temperature, we call them as isotonic solution. Example, the osmotic pressure that is associated with the fluid inside the blood cell. Blood cells, inside the blood cells there is a fluid. So the osmotic pressure of the fluid inside the blood cell, it is equivalent to the osmotic pressure of 0.9% of NaCl solution. It is known as normal saline solution. So it will be equal to this 0.9% of NaCl solution, the osmotic pressure of the fluid inside the blood cell. So this is an example for isotonic solutions. Now, this injections, that is intravenous injections, normal saline will be given. So the strength of the normal saline will be of 0.9%, because if that 0.9% of NaCl is injected, see our blood cells will remain intact and nothing will happen to our blood cells, and so it is safe to inject this 0.9% of NaCl solution, that is normal saline solution. Okay, next we move on to hypertonic solution. Hypertonic solution means a solution having higher osmotic pressure than that of a given solution. We call it as hypertonic solution. So here the osmotic pressure of the given solution will be higher. Hyper means higher. So such a solution we call it as hypertonic solution. Example should be studied carefully. See, if we place the blood cell in a solution containing osmotic pressure more than 0.9% of NaCl solution. So if you are placing the blood cell in a solution having higher osmotic pressure than that of 0.9% of NaCl solution, what will happen is that, see, the water or the fluid that is present inside the cell, it will flow out of the cell. The fluid present in the cell, it will flow out of the cell, and as a result the blood cell will shrink. Okay, so this is the example for hypertonic solution. So in a hypertonic solution, the blood cells will shrink. Okay, now hypotonic solution. Hypo means less. So a solution having lower osmotic pressure than that of a given solution, they are called hypotonic solution. Now if we place the blood cells in a solution where the salt concentration is less than 0.9%, then what will happen is that water will flow into the cells and the blood cells will swell. Okay, so in hypotonic solutions, here the blood cell is placed in a solution, NaCl solution, having lower osmotic pressure. So here what happens is that, see, the water will flow into the blood cell, and as a result the blood cell will swell. So this is about hypotonic solution. So you have to be clear with the examples for hypertonic as well as hypotonic solutions. Next we will see reverse osmosis and water purification. So here this is a 2-mark question, reverse osmosis and water purification. So we have studied osmosis in the last session. What is osmosis? Osmosis is defined as the flow of the solvent from pure solvent to the solution. Okay, so that is known as osmosis. So here we are trying to reverse the direction of osmosis. Okay, now the direction of osmosis can be reversed if a pressure higher than the osmotic pressure is applied to the solution side. That is, we already know what is osmotic pressure. The pressure that is required to stop the process of osmosis, that is called osmotic pressure. So the direction of osmosis can be reversed. We can reverse the direction of osmosis, can be reversed. How? If a pressure larger than the osmotic pressure is applied on which side? Solution side. Now what happens when we apply a pressure higher than the osmotic pressure on the solution side? What happens? See, the pure solvent flows out of the solution through the semi-permeable membrane, and this phenomenon is known as reverse osmosis. Reverse osmosis, it is used in the desalination of seawater. Okay, now I'll explain this. That is, seawater means what? Saline water or salt water. So salt is dissolved in the water, so we can call sea water as a solution. Okay, now here we are going to apply a pressure. That pressure should be greater than the osmotic pressure. You can see here pressure should be greater than the osmotic pressure is denoted with the symbol pi. So the pressure applied should be great. This is the piston, and by lowering the piston we can apply a greater pressure, and the pressure should be greater than the osmotic pressure. When we apply a pressure greater than the osmotic pressure on the solution side, or this here it is seawater. So what happens? The pure solvent in seawater, what is a solvent? Salt plus water will give you salt water. So here solute is salt and solvent is water. So when you apply a pressure larger than the osmotic pressure, the solvent molecule, that is water molecule, it will flow through the semi-permeable membrane. You can see this black demarcation, that is a semi-permeable membrane. Through the semi-permeable membrane, what happens when a pressure larger than the osmotic pressure is applied on the solution side? See, the water molecule or the solvent water from the seawater, salt water, it will flow through the semi-permeable membrane, and this process is known as reverse osmosis. Okay, that process is known as reverse osmosis, and reverse osmosis is used in the desalination of salt seawater. In order to remove the salt from seawater, that process is known as desalination. So for that process we are using reverse osmosis. So you have to study this diagram and these steps. Okay, so this is about reverse osmosis and water purification. For this process to happen, we have to apply a pressure larger than the osmotic pressure. Now, when the pressure more than the osmotic pressure is applied, what happens to this to this salt solution? Pure water will be squeezed out. Pure water will be forced to move out of the seawater through this membrane, and the pressure required for the reverse osmosis is very high. Okay. Now, a semi-permeable, usually in this process, desalination plants, a semi-permeable membrane, okay, of cellulose acetate and is used. Cellulose acetate is a semi-permeable membrane used, and that is permeable to seawater. That means it will allow only, it is permeable to water, sorry, not seawater. It will allow only water to flow through it. It is permeable only to water, but it is impermeable to impurities, but it will not allow the impurities to flow through it. And the ions, there is a spelling mistake here, it is IONS, IR. And ions present in the seawater is used in the desalination. So that is a semi-permeable membrane of cellulose acetate that is permeable to water, but it is impermeable to impurities, but it will not allow the impurities such as ions that is present in the seawater to pass through it. Only water will be allowed to pass through. And so this is about the reverse osmosis. Next, we have to study a small topic, that is abnormal molar mass. That is, when ionic compounds are dissolved in water, it will dissociate into positive and negative ions. Okay, so when ionic compounds, it will dissociate into positive and negative ions, that is cations and anions. Example, when 1 mole of KCl, that is potassium chloride, when it is dissolved in water, it will dissociate into 1 mole each of K plus ion and Cl minus ions. So you have to understand one thing. Whenever there is dissociation of the solute into ions, the experimentally determined molar mass, okay, experimentally we will calculate the molar mass. The experimentally determined molar mass will always be lower than the true value. Okay, so this is how in the case of ionic compounds, when the ionic compounds will definitely dissociate into positive and negative ion. So in the case of dissociation, the experimentally determined molar mass, it will be much lower than the true value, expected value. Now, next one, molecules of ethanoic acid. You know, ethanoic acid is acetic acid, CH3COOH. It will dimerize. That means 2 molecules of ethanoic acid, they will join together, dimerize in benzene due to hydrogen bonding. In this case, the number of particles is reduced due to dimerization or association. Okay, so in the case of molecules of ethanoic acid, 2 molecules of ethanoic acid, that is CH3COOH, they will dimerize, that is 2 molecules, they will join together. Okay, that process is known as dimerization. How will 2 molecules of acetic acid join together? Through hydrogen bonding. In this case, what happens? The number of molecules or number of particles is reduced. That is, initially two molecules were there, they joined together and became one molecule. Okay, so in this case, in this particular case of dimerization, the number of particles is reduced, and this process is known as association. That process is known as association. Okay, so in the beginning, ionic compounds means it will undergo dissociation and will split into positive and negative ion, whereas acetic acid molecule means instead of dissociating, they are not ionic compounds, they are organic molecules. So they will associate. How they will join together? Through hydrogen bonding. Two molecules will dimerize through hydrogen bonding and become one molecule, and that process is known as association. Now, in the case of association, you should see one thing. The molecular mass in this case, calculated in this case, it will be twice than the expected value, because two molecules are joining together. So definitely the molecular mass will be, in this case, will be twice than the expected value. Such molar mass is either lower or higher than the expected or normal value. Okay, is called abnormal molar mass. Okay, so here two cases we saw. One is dissociation. In the case of dissociation, KCl will split into K plus and Cl minus ion. So we said that in the case of dissociation, the molar mass will be expected, or experimentally determined molar mass will be lower than the true value. But in the case of association, second case we studied, that is two molecules of ethanoic acid, they will join together and they will form one molecule. The molar mass calculated will be twice than the expected value. So there is a difference in the molar mass than from the expected value. Okay, so such molar mass which is either lower or higher than the expected or normal value, they are called abnormal molar mass. Now next we will see Van Hoff. Okay, he introduced a factor, and that factor is known as I. We represent that factor as I, and it is known as Van Hoff factor, in order to account for the extent of association or dissociation. What is the effect of association or dissociation? In order to account for that, he introduced a factor, and that factor is denoted with the symbol I. Okay, this is called Van Hoff factor. The Van Hoff factor I is defined as follows. I is equal to normal molar mass divided by abnormal molar mass, observed colligative property divided by calculated colligative property, then total number of moles of particles after association or dissociation divided by total number of particles before association or dissociation. So please study these equations. So normal molar mass divided by abnormal molar mass will give you the value of I. Again, another way to find I is observed colligative property. Colligative property means we have studied 4 colligative properties. So relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, as well as osmotic pressure. So observed value for the colligative property divided by the calculated value of colligative property. Or one more method is there, the total number of moles of the particles after association or dissociation, depends on the type of the compound. If it is an organic compound, it will undergo association, or means if it is an ionic compound, it will undergo dissociation. Total number of moles of the particles after association or dissociation divided by number of particles before association or dissociation. So please study this equations. In the case, now again another one more question is coming. In the case of association, if two molecules are combining together, in the case of association, the value of I means Van Hoff factor I, it will be less than unity. In the case of association, the value of I will be less than unity. In the case of dissociation, the value of I will be greater than unity. Okay, so that is I will be greater than unity means I value will be greater than 1. Okay, so association means I will be less than 1. In the case of dissociation, the value of Van Hoff factor I will be greater than. You have to study it very carefully. Now calculate the Van Hoff factor I for the following compounds. Okay, now first let's see NaCl, ionic compounds only we are seeing. First NaCl, you know NaCl it will split as what? Na plus and Cl minus. So one Na plus and one Cl minus. So how many it has dissociated into how many ions? 2 ions. So the Van Hoff factor I, it is equal to, for the complete dissociation of the solute, what is it? It is 2. So NaCl, it will split into Na plus and Cl minus. So what is the so 2 ions we are getting, Na plus ion and Cl minus ion. So what is the value of I? I is equal to 2. In the case of KCl, KCl means, you know, it will split as K plus and Cl minus. So K plus means 1 K plus and 1 Cl minus. So total number of ions is 2. So Van Hoff factor I for complete dissociation of KCl is what? 2. Now in the case of MgSO4, you know, MgSO4 means magnesium sulfate. Magnesium sulfate will split as what? Mg2 plus and SO4 2 minus. See here you should see only the number of ions formed. Don't see the charge above the ions. See, magnesium means it will split as Mg2 plus. It is the charge on it. And SO4 2 minus. Actually MgSO4 is splitting into what? Mg2 plus and SO4 2 minus. How many ions we got? Mg as well as SO4. So what is the Van Hoff factor I for that? It is 2. Next, coming to the last one, that is K2SO4. K2SO4 means what? Potassium sulfate. So potassium sulfate means how many K is there? 2K. So it will split as what? 2K plus ions. How many K plus ions? 2K plus ion and 1 SO4 minus. 2K plus and 1 SO4 minus ion. So how many? What is Van Hoff factor value I? That is I is equal to 3 because it is splitting into 3 different ions. One is 2K plus ions and 1 SO4. So 2K plus and then 1 SO4 2 minus. Totally 3 ions are there. Therefore the value of Van Hoff factor I is equal to 3. I hope you have understood this chapter. That's all. This chapter is over and you have to write the notes in your classwork and then you have to go through each and every concept of this chapter. Thank you.